All right, so we are now recording. So the question was, what do we have due this week? For this week, we have your pack back. So ask a question, answer two. You'll have the assignment number 3 that's due, which is an optical illusion infographic. Now, an infographic, put simply, is you get creative and do this however you want to do it. The two components to that, an infographic, are pictures and words describing the pictures. So for this week, what we're going to be looking at doing is having you select an optical illusion. And it could be something that you find on the internet. It could be something that you see in the book that you want to explain. And so pick an optical illusion, one that what you're seeing isn't necessarily what somebody else would see. And why is that? So that would be the second part. Explain based on the book. Your book offers a couple different perspectives. You have the Gestalt principle, you have the top down, and you have the bottom up processing. You have the linear, what am I thinking of? With the horizon, the linear perspective, size constancy, linear constancy, that's what it was, and size constancy. So what forces are at play that are making you see something that's either not there or that somebody else would see differently? That's basically, and you can put it in a Word document, you can put it in a PDF, whatever you want to do. Get creative with this. But those would be the components that I'm looking for: is what is the picture, what is your explanation for the picture, and then of course you're going to have your reference at the end. Where did you get your information from? Okay, and most of the time, most students just use the textbook. All right, the other part is going to be the quiz, which is due Sunday. And I think that's it for this week. Next week, week 4, of course, you'll have your group work. Now, in the other classes, I've had some of the students were a little bit, they're getting a little excited and worried because some of the students aren't responding right away. So Thursday, or tomorrow, I should have your groups already picked. So I'll let you know when I do have them set up so you can go and look at them. And how you'll find your groups is if you go into D2L under content and the group project discussions. Right now, I think you'll see like group A, B, C, D, E, F, or something all the way up to F. When you get your group assigned, you'll only see your group in there. That'll be the only one that you see, and it'll show who else is in that group for you. So once you have that, get in there and say hello and start talking about how you want to connect. It may be via Zoom, it may be via Facebook or FaceTime, not Facebook, FaceTime or some other way. So start generating ideas, because that's going to be the assignment next week on the end of week 4 is how is your group going to communicate? How are you going to overcome obstacles? Because many of you are full-time students. Some of you, I know I've talked to, are full-time students and full-time employees. Some of you have families on top of that or aside from that, right? So everybody's lives are going to be different, and some of you may have more time than the others. So keep that in mind as you're going through, is that somebody might just be busy and doesn't have a whole lot of time, and how are you going to overcome those obstacles to reach those people and be involved, okay? Try to think what else. All right. Any other questions? All right. So if anything does come up, of course, just put it into chat, and Jen will have a couple stopping points where Jen can ask them along the way. All right. All right. So let's get to it. So this week, okay, I'm recording already. So this week we are talking about sensation and perception. Now, what's the difference between sensation and perception? Who is up on the lingo here? Who's up on the terminology? Who read in the book? What is sensation and what is perception?
I remember perception is the way you see something, like as soon as you look at it.
Okay, sensation and perception. So you said that was perception is the way that you look at it? Which one? I'm sorry, can you say that one more time?
It's like the way you see something.
Sensation is?
Perception.
Perception, the way you see something. Okay. the way we see something. Okay. So what is sensation? Anybody care? What is sensation?
It's like a feeling.
I was gonna say it's your five senses, like how your brain interprets the five senses, and like when you feel
Okay.
something or something.
Okay. So I'm perfectly done with the exception of one word. It's how your, what'd you say? How your brain what?
I said like how your brain interprets like the
Okay.
five senses.
Okay. So interpretation, believe it or not, is the perception. Okay. Interpret. Now I want to take all of you back to when you were 6 months old. Who remembers when they were 6 months old? Of course you don't, right? Our memory doesn't go that far back, at least as far as I know. Does anybody here remember when they were 6 months old? I'll be impressed. Okay. So when we were 6 months old, the world was new, right? We didn't have words for things. We didn't have the experience to know what things do. We learned that throughout our childhood. So when we think of sensation, we think of the activation of receptors, okay? So that's the activation of receptors. Now, receptors, if you remember from last week, are the actual neurological connectors at the end of our fingertips, or the olfactory receptors within our noses or in our taste buds, right? They could be the rods and the cones in our eyes, which I'll explain what the differences are. It could be the tiny hair follicles within our cochleas, within our ears, that pick up certain ranges, right? So one of our five senses. So what are our five senses, by the way? Anybody know? I just mentioned a couple of them.
Touch, taste,
Touch, taste,
smell, sight, hearing.
sight, hearing, and touch, taste, and somebody say smell.
Smell.
Yeah, exactly. So our five senses. Actually, taste and smell are they use the same olfactory sense, but we consider them different senses because they're different parts of our body, and we can kind of relate to that. We can say that most of our senses are co-located in one clump area. For example, our vision. Our vision, we can say, is really limited to our eyes, right? We can say our hearing is limited to our ears. We can say our taste is limited to our tongue, and our smell, our nose. But what about our sense of touch? Our pain receptors, our touch receptors, our pressure receptors, they're all throughout our body, aren't they? So we can't really say that they're all co-located with each other in one specific area. So anyway, our sensation is the activation, sensation is the activation of those receptors that then send a signal to our brain. Now our brain, once it receives those signals, based on experience, it tells us what those signals are and what we're going to do with them. So that's the interpret part, as one of you had said earlier. So put simply, perception, oh, for some reason not writing now. So perception is the methods, let's see, by which, let's see, sensations are organized and interpreted, right? Now that's important, interpreted. Now that's important to remember, because when we lose one of our sensations, for example, a video I'm about to show you here in just a little bit, when somebody loses one of our senses, for example, sight, we lose our ability to visually see something. Does that mean that our occipital lobe is no longer active? Not really, okay? It doesn't mean that at all. In fact, it's still active. It's still, our occipital lobe helps with vision, and we call it our visual cortex, but we are still aware of our surrounding through our other four senses. In fact, now that sight is no longer there, we have really a heightened sense of our other four senses. So we're able to really understand what our environment is around us still without the vision, which the gentleman I'm going to bring up for you next is going to describe. 1 second here, let me share my screen with you, my other screen. All right, so pay attention to this video. It's only about, it's about 13 minutes long, but I want you to kind of pick out what this message means to you, what it is that Daniel Kish is talking about here, okay? Oh, hold on a second, hold on. I don't think there's a way to do this properly, and I think I might have, did it look jumpy and sound bad? Try it this way. Can y'all see it?
I was born with bilateral retinoblastoma, retinal cancer. My right eye was removed at 7 months of age. I was 13 months when they removed my left eye. The first thing I did upon awakening from that last surgery was to climb out of my crib and begin wandering around the intensive care nursery, probably looking for the one who did this to me. Evidently, wandering around the nursery was not a problem for me without eyes. The problem was getting caught. It's impressions about blindness that are far more threatening to blind people than the blindness itself. Think for a moment about your own impressions of blindness. Think about your reactions when I first came onto the stage, or the prospect of your own blindness, or a loved one going blind. The terror is incomprehensible to most of us, because blindness is thought to epitomize ignorance and unawareness, hapless exposure to the ravages of the dark unknown. How poetic. Fortunately for me, my parents were not poetic, they were pragmatic. They understood that ignorance and fear were but matters of the mind, and the mind is adaptable. They believed that I should grow up to enjoy the same freedoms and responsibilities as everyone else. In their own words, I would move out, which I did when I was 18. I will pay taxes. Thanks. And they knew the difference between love and fear. Fear immobilizes us in the face of challenge. They knew that blindness would pose a significant challenge. I was not raised with fear. They put my freedom first before all else because that is what love does. Now, moving forward, how do I manage today? The world is a much larger nursery. Fortunately, I have my trusty long cane, longer than the canes used by most blind people. I call it my freedom staff. It will keep me, for example, from making a undignified departure from the stage. I do see that cliff edge. They warned us earlier that every imaginable mishap has occurred to speakers up here on the stage. I don't care to set a new precedent. But beyond that, many of you may have heard me clicking as I came onto the stage. with my tongue. Those are flashes of sound that go out and reflect from surfaces all around me, just like a bat sonar, and return to me with patterns, with pieces of information, much as light does for you. And my brain, thanks to my parents, has been activated to form images in my visual cortex, which we now call the imaging system, from those patterns of information, much as your brain does. I call this process flash sonar. It is how I have learned to see through my blindness, to navigate my journey through the dark unknowns of my own challenges, which has earned me the moniker, the remarkable Batman. Now, Batman, I will accept. Bats are cool. Batman is cool. But I was not raised to think of myself as in any way remarkable. I have always regarded myself, much like anyone else, who navigates the dark unknowns of their own challenges. Is that so remarkable? I do not use my eyes, I use my brain. Now, someone somewhere must think that's remarkable, or I wouldn't be up here. But let's consider this for a moment. Everyone out there who faces or who has ever faced a challenge, raise your hands. Whoosh. Okay, lots of hands going up. A moment, let me do a head count. This will take a while. Okay, lots of hands in the air. Keep them up. I have an idea. Those of you who use your brains to navigate these challenges, put your hands down. Okay, anyone with your hands still up has challenges of your own. So we all face challenges, and we all face the dark unknown, which is endemic to most challenges, which is what most of us fear, okay? But we all have brains that allow us, that activate to allow us to navigate the journey through these challenges, okay? Case in point, so I came up here and they wouldn't tell me where the lectern was. So you can't trust those TED folks. Find it yourself, they said. So, and the feedback from the PA system is no help at all. So now I present to you a challenge. So if you'd all close your eyes for just a moment, okay? And you're going to learn a bit of flash sonar. I'm going to make a sound. I'm going to hold this panel in front of me, but I'm not going to move it. Just listen to the sound for a moment. Okay, nothing very interesting. Now, listen to what happens to that same exact sound when I move the panel. You do not know the power of the dark side. I couldn't resist. Okay, now keep your eyes closed, because did you hear the difference? Okay, now let's be sure. For your challenge, you tell me, just say now, when you hear the panel start to move, okay? We'll relax into this. Good, excellent. Open your eyes. All right, so just a few centimeters, you would notice the difference. You've experienced sonar. You'd all make great blind people. Let's have a look at what can happen when this activation process is given some time and attention.
It's like if you guys can see with your eyes, and we can see with our ears.
It's not a matter of enjoying it more or less, it's about enjoying it differently.
Goes across,
Yeah.
and then it's gradually coming back down again.
Yes.
That's amazing.
Isn't it?
I can like see the car. Holy mother.
Yeah, I know. We're passing a tree on the right. I think you're okay.
I love being blind. If I had the opportunity, honestly, I wouldn't go back to being sighted.
The bigger the goal, the more obstacles you'll face. And on the other side of that goal is victory. Stop.
E allora! E allora! E allora! È stato bellissimo vederlo, Juan. Vieni, vieni.
Now, do these people look terrified? Not so much. We have delivered activation training to tens of thousands of blind and sighted people from all backgrounds in nearly 40 countries. When blind people learn to see, sighted people seem inspired to want to learn to see their way better, more clearly, with less fear, right? Because this exemplifies the immense capacity within us all to navigate any type of challenge, through any form of darkness, to discoveries unimagined when we are activated. I wish you all a most activating journey. Thank you very much.
Daniel, my friend, that, as I know you can see, is a spectacular standing ovation at TED, and thank you for an extraordinary talk. Just one more question about your world, your inner world that you construct. We think that we have things in our world that you as a blind person don't have, but what's your world like? What do you have that we don't have?
360-degree view. Okay, so my sonar works about as well behind me as it does in front of me. It works around corners. It works through surfaces. Generally, it's kind of a fuzzy, three-dimensional geometry. One of my students, who's now become an instructor, when he lost his vision after a few months, he was sitting in his three-story house, and he realized that he could hear everything going on throughout the house. Conversations, people in the kitchen, people in the bathroom, several floors away, several walls away. He said it was something like having X-ray vision.
What do you picture that you're in right now? How do you picture this theater?
Lots of loudspeakers, quite frankly. You know, it's interesting. When people make a sound, when they laugh, when they fidget, when they take a drink or blow their nose or whatever, I hear everything. I hear every little movement that every single person makes. None of it really escapes my attention. And then, you know, from a sonar perspective, the size of the room, the curvature of the audience around the stage, it's the height of the room. Like I say, it's all that kind of three-dimensional surface geometry all around me.
Well, Daniel, you have done a spectacular job of helping us all see the world in a different way. Thank you so much for that, truly.
Thank you.
That was amazing.
All right. So what were some cool things that you picked up on from Daniel?
I've always known that when people lose their sight, their hearing usually gets better to make up for it, but I never knew they could actually do that sonar thing. That's completely new to me.
Yeah, it's cool stuff.
Probably how he was able to describe it.
How he was able to articulate what it was to not have your sight.
And describe the auditorium without seeing it.
Oh, yeah. Okay. So describe his surrounding. Like he said something really cool in there. Did anybody else pick up on this? He said, I don't use my eyes, I use my what?
Brain.
His mind, right? He uses his mind, absolutely. So instead of, we look at the occipital lobe and the visual cortex as our area where we can geospatially recognize the room around us without even having our eyes open. So many of you, in fact, let's try this now. What I'd like everybody to do, I think we did this before, is to close your eyes, okay? Everybody just kind of close your eyes. And anybody want to describe how many feet the wall is behind them without looking? I see a couple of you. Jennifer, are you looking at your wall behind you?
My dog came into the room, sorry.
Okay. I said describe or talk about how far the wall is behind you. I saw you look around.
No, my dog walked in, sorry.
All right. How far is the ceiling above you? What do you have in front of you? What do you have off to your right and your left? You don't need your vision to see those things, right? Because you've seen them, so to speak. You can reach out and touch them. And if you had attuned hearing, your hearing was improved, you would be able to hear them, or at least do what echolocation. What he's talking about is making those clicking noises to see the room around you. So in a lot of ways, yeah, I mean, his other senses have improved, but his visual cortex is still intact. His spatial memory is still activated, which is kind of cool, right? So what were some other, maybe one more, what was another really cool message you got out of Daniel in this video?
The way that he was trying to find things with the sound of like making that clicky sound with his tongue.
Okay. Figuring out a way to activate his senses, right? His heightened senses. He talked about his student who was newly blind, and he was able to describe what was going on in his 3-story house without even being there, right? One of the messages that I really got out of him is being immobilized by fear. And this is going to come up a lot, especially when we talk about motivation, when we talk about personality, and even mental health disorders, because fear really confines us. Fear keeps us from thinking outside the box and doing things differently. And I shared this with my other class because we are two things. What are we as humans? Anybody remember? Anybody? Ooh. And my last class didn't remember this either. We are lazy and proud, right? Of course, using lazy in the most endearing terms, we like to have things in routine. We like to have things that make sense in our lives. We like things to be easy, because when they are routine and easy and make sense, our stress level is what? Reduced, right? So we strive for that. We strive for regularity. We strive for schedules. We strive for things to make sense to us, because when they don't, we start experiencing a little bit more stress when we have new things in our environment, okay? And that's what I mean by lazy. We like routine. So what he's talking about is when things aren't routine, and we have to get used to something new, activating areas of our brain and thinking outside the box and being creative to overcome those obstacles is going to serve you best, okay? And you think about, many of you are here because you overcame fears of some sort to step outside that box and do something new. Maybe some of you have come from a line of family that have gone to college, and you know what that's like. And then I'm guessing a good many of you probably have had relatives or parents or caregivers that didn't go to college, and you're the first in your line to do that. That's thinking outside the box. That's doing something different and conquering your fears. And that's really powerful stuff. And I commend anybody that does that, okay? All right, so in regards to sensation, we'll go into perception a little bit more on Friday, but I do want to give you just a couple of key concepts here. Let me share my screen. All right, in reference to our senses. As we said, the sensations are the activation of receptors that then go to our brain for later processing or perception, right? So before that has to happen, we have to be able to sense something. We have to be able to take that information in. And in order to do that, our senses have to be activated. Now, a lot of things go into that. Have they been activated before? Is this a new sensation that we have to interpret a little bit differently? So for example, again, if I asked you to close your eyes and I snap my fingers, okay, maybe you can hear that. You know what that sound is because you've encountered that before. You've seen that before. You may have done that before. So you know what those sounds are. Your brain is processing that into something that was familiar to you at some point. So the first term I have for you is absolute threshold. Now, absolute threshold is the minimum minimum energy, to detect 50% of the time, okay? So what does that mean? So for example, if you have a candle, you're in a dark, maybe the dark woods or something, and then off in the distance, somebody is holding a candle. For you to be able to see that candle, it would have to probably move a little bit closer, right? Because the further away, your eyes may not pick that up. But the closer they get, you may pick that up. So the 50% of the time is that range in which your senses are able to say, oh, I see something there. I'm able to detect that. Many of you that have had audiology, checking your hearing. Anybody have audiology tests done before? Where they test your hearing. What do? They play things at different thresholds, right? Because they're measuring 50% of the time that you're able to pick up that faint sound. And that's what they're saying, that's what they're writing down in their report as you having detected, is that 50% of the time you're able to hear that tone within that range and at that decibel, okay? Now that's a little bit different than what we call the just noticeable difference. Okay, just noticeable difference is similar in that it's the minimal difference or minimal change that's detected to detect 50% of the time. So let me give you an example of that. Oops. So for my live classes, I've done this in the past, and this is kind of a fun little experiment. Before the students walk into the auditorium or the classroom, I have a mid-range tone that is playing right around 8 decibels. Not even worth mentioning. Like if you walked into a room, it would just be like a really low hum. It's not interfering with you in any way. But every minute, I would turn up another decibel until we got to about halfway through the class, about 20, 30 minutes later, and it's at a really audible tone. I mean, if somebody walked into the auditorium or the classroom, they would say, oh my gosh, what is that noise? What do you think the students in the class were doing? Do you think any of them really noticed? Not really. And I wish I could have done this on Zoom, but if I could have figured out a way to do that and swap audio and play videos, well, I'll get there eventually one day with technology, but not there yet. But almost nobody in that classroom was able to detect that noise unless somebody from outside came in and said, hey, what's that noise? And then they say, oh my gosh, that's right. Maybe you can relate to this. You have a roommate or a family member. How many of you relate to this? That maybe had the stereo going or the TV going, and they kept turning it up throughout you sitting there or being in the room or something. And until you get to the point where you can't even hear yourself think, or you are shouting to talk to them, right? How many of you have experienced that? That happens. So same thing that's happening here. Now, if I were to change up that experiment, and instead of every minute, upping at 1 decibel, instead upping at 5 decibels, and then I get 50% of the class, it says, hey, I just noticed something new. That would be just noticeable difference, okay? Does that make sense? So I wanted to kind of just describe the difference between these two, all right? So the other thing I do want to discuss is, we spend a lot of time, your book goes through all 5 senses. Unfortunately, we don't have that kind of time to go through all these, but another area that students seem to benefit from understanding is how we take information in through our eyes, okay? Because we are not necessarily, and this is gonna kind of play into your assignment for this Sunday. So when we're sensing colors and we're sensing patterns, we do that through a series, the information, the stimulus, the image enters our cornea or our iris in our lens and projects on the back of our retina, right? The back of our eye wall.
And the image is upside down, correct?
Yes. So, and that's just basic optics, is when you have a lens and you broadcast an image through that lens, it appears upside down, unless you have other lenses that convert that back, okay? But this is just like a concave lens. There's really nothing that's reverting it back to. So it does. It shows up on the back of your eye wall as upside down. But your mind, and this is where perception has kind of changed that for you, because we know, based on our own experiences and maybe based on what we've learned with physics, is that if we drop something, it's going to go where? It's going to go down, right? Now, on the back of our eye wall, it may appear that it's going up, but we know to reach down for that. It's just through experience that we've adapted to that. And there have been awesome experiences or experiments out there where they give people inverter glasses and they have them adapt to the world around them. And it takes a couple days for them to get used to doing things, but they're trying to cook and clean and wash and write, trying to do everything while it's showing as up here. But eventually they can adapt to that, because that's what we do. We adapt to things, right? So on the back of this eye wall, at the back of our retina, we have a bunch of sensors called cones and rods. Now our cones are responsible for what? For color, okay? Now as humans, we are probably more apt, we see colors better than most other species because we are day survivors. We are not nocturnal, right? And we also have rods. Now our rods are spread out a little further away. And the reason for that is when it gets dark, our iris, it dilates, it expands to let more light in. Now, although we are able to see black and white a little more readily available with rods, we are really far away from any kind of nocturnal animal, because they're able to process images in the dark a lot better than we are. They're able to get a little bit more light into their eye. Their rods are much more sensitive, and therefore they have better night vision than we do, which is another reason, and when we talk about this next week, when we get into states of consciousness, why we sleep at night, because we are not prepared to thrive during the night, okay? Most of us. So anyway, that's just the basics of the eye structure. So the takeaway of that is cones process color and rods process black and white. And that'll, again, we'll talk more about perception and how that plays out in perception on Friday. All right. Any questions up to this point? Or anybody have any comments? Go ahead.
Only question I have is, how important is it for students to recognize the structures of the eye?
You mean
for like tests and stuff?
Oh, you probably have some questions in your quiz about it. You know, I don't go into depth with this. I do in biopsychology, which I'm not teaching here at ESU. But there are reasons that we would go more in depth into the sensory receptors in the eye, like the cones and the rods. I even go into hearing a little bit more. It's just we don't have the time to really delve into this, but I do want you to understand how sensory receptors work, how we take the information in through these sensory receptors. They travel along the neurons to our brains, and then our brains, which we'll talk about on Friday, how we perceive those signals based on experience, okay? So not going too in the weeds on this stuff. Now, your book talks about it, and again, it doesn't go too far into the weeds with it as well, but yeah, I mean, understand the basic structures, you know, how light enters and what sensors are activated, especially with the cones and the rods, okay? Anything else?
That's all I have.
Okay. All right. Anybody have anything for me or any comments, anything cool that, or the questions that they heard about hearing or sight or touch or sense or smell?
Do we have a pack back due this week?
We have a pack back due every week. So if you get to the end of the week and you're questioning, do I have a pack back due this week? The answer is yes.
Are the questions supposed to revolve around the same thing?
Yes. Yep. The question should be something to do with sensation and perception.
Okay.
Okay. All right. I'm going to hang around for just a few minutes here. If any of you need to talk with me one-on-one. That's all I have for you today. I hope the rest of you have a great rest of your day, and I will see you here on Friday. All right?
You do the same.
Have a good day, guys.
Bye. Thank you.